anytime we've seen the syntax x dot something, when you see the dot, that means that we're using objects and we're using object-oriented programming. We just have not written very many objects, haven't written very many classes. An object is an instance of a class. You define your class, it's the template for the class, the blueprint for it. And an object is an element, a variable that contains all the variable types that were defined as part of that class. And you can call all the functions, all the methods that are defined as being part of that class. Here we're going to use this fancy term, abstract data type, which I'm going to Google because I consider an abstract data type to be something slightly different. But okay, an abstract data type, a mathematical model for data, where data is defined by its behavior. Okay, so anyways, an abstract data type, you are getting to define the data, right? You're going to define a patient class, and it's going to have a first name and a last name and a patient ID number and a home address and all that kind of stuff. What is the difference between an ADT and a data structure? To put it simply, ADT is a logical description and a data structure is concrete. Oh, forget that. Okay. So the limits of procedural programming. It's called procedural because it's pretty much top-down. The program starts at main, it calls some procedures, functions. Those functions execute, they exit, and then you have some loops and it's done. Programs that are based on complex function hierarchies can be difficult to understand and maintain, difficult to modify and extend, easy to break. For example, a program like PowerPoint. If you tried to write this as a procedural program, it'd be flat out impossible. Graphical user interfaces, the programming for that only became simpler when classes were written that managed the display of things like what happens when you click on a menu. And it's got some sub-menus. And what happens when you click on a sub-menu? How does that call a function? Well, until people had written classes that helped you write all this stuff, then writing a graphical user interface program was extraordinarily difficult. Like back in the days of Windows 3 and Windows 95 and the early Mac programs. Mac not so much. Macs did actually use object-oriented programming. Okay, so our terminology, a class is like a structure. It bundles related variables, but then you can also add functions. And the object is an instance of the class. You can create a string object or a file object. So the class is the blueprint. The objects are all the houses built from the blueprint. And they don't have to all be identical. Part of your blueprint may be what color the house is, and each house could have a different color. Each house will probably have a different street address. Each house may have a different countertop material, granite countertops for the fancy people rather than, plywood, whatever. So the attributes are the members of the class, and the methods or behaviors are the functions of the class. We will call them methods. And I will tend to call the attributes the variables, just because these terms go across whatever object-oriented programming language you are, but the inventor of each language decided that they needed to be referred to in slightly different ways. Some person's attribute may be somebody else's member variable, it may be somebody else's property, for example. But we know what a variable is in our head, right? And so a variable that is part of a class is a member of that class, so it's a member variable. That's the term that I'm going to use, unless I'm reading it off the PowerPoint. So you use the class keyword, then you follow it with the class name. Modern tradition is that all your class names begin with an uppercase letter, and all the variables that are created from them begin with lowercase letters. And then you have all your declarations, just like we had variable declarations inside our structures. You can have private parts and you can have public. Here are the private members. Width and length are private members of the rectangle class. And then we have some functions, the methods. This is known as data encapsulation, when you make your data private and then your methods public. The reason you do that, the reason you encapsulate it, a couple of reasons. One is so that if you want to go to the trouble, you can ensure that these values never hit invalid values. You may define that a rectangle is something that has a non-zero or non-negative width or length. And then you may make set width and set length forbid zero or negative values. In which case, once the rectangle is created and it is initialized with valid values for the width and the length, it can never hit an invalid state. The program cannot mistakenly set those set those values to invalid values. They're kept in a valid state at all times by having what are known as the setters or the mutators do the error checking and make sure that they do not get to set to invalid values. That's one reason. Another reason to do data hiding, which is where you hide the data from the calling code, from the driver class, from main, is so that the implementation of the internal data does not matter to the person who's using the class. I can give you a class, it's a rectangle class, you're going to use it, you don't care how the width and the length are stored, as long as you know that you can set the width and you can get the width, and that when you set the width and get the width, then they're doubles. But you don't know what's going on behind the scenes. You don't know whether these values are being stored in an array behind the scenes for some reason, or some kind of list, a vector list of values, or something esoteric. And then you don't need to know if all that stuff changes. I rewrite the class because I think the idea of storing all these values in an array is ridiculous. Or I decide so that every time you call set width, it logs that change somewhere that could be then viewed by the application, right? All the other programmer needs to know is that they can create a rectangle and then they can call those functions. That's all that they should have to know about it. So the access specifiers control access to it. And we have already talked about public and private. If something is declared as public, then the driver code can access it. If something is declared as private, it can only be called by functions that are members of the class. And when you talk about inheritance, there's a third type that becomes important, which is called protected. Protected means that it's private to the outside code, but is public to everything inherited from it. We'll get to that later. So access specifiers. This example shows all the private ones listed up at the top, and then all the public ones. You can list them in whatever order. Don't have to list them in any specific order like that. You can change them on an item by item. You can say private, double width, public, set width, private, double length, public, right, whatever. This is a common way of doing it, though. Breaking it down, you list all the encapsulated, the data hidden members up at the top, and then you list all the methods underneath it. Just use the public keyword once. The Java programmers are used to specifying it for every value. So if you look at C code and every single variable has private colon in front of it, then you know that that person came to this language from Java. If something is not specified, the default is private. Opposite of Java, where if something is not specified, its default is almost public. It's project, meaning that any code in the same project can access it. You could use const. Const means that that code does not change the value. When you call get width, it's not going to change anything inside the rectangle. And you can say that, okay? That's not going to change it. Your setters, set width, set length, and set are not going to be able to be marked as const because they actually change the data in it. And we haven't been using the const keyword enough for that to really click and to understand why we might want to do that. But we're going to do that now. So I'm going to make a new C++ project. run. Come on. Really? And to answer the question, we are on lecture X. Alright, so I'm going to go to source files. I'm going to add a main for source.cpp, but then I'm going to add a class as well. So source.cpp, I'm going to paste my boilerplate into it. But then I'm going to create a class. And for now, I'm going to go ahead and put it into the same code that main is in. But to be a better programmer, what I should be doing is I should be putting them in their own files. And I believe we gave one example of that earlier, maybe two. So anyways, let's do the rectangle class that they're doing, or at least a circle class. So public, nope, rewind. Class circle, open brace. Now every class has a radius, so int radius. And we're going to have a getter and a setter. So void get radius. And what does it do? It returns radius. And then void set radius. It's giving me a problem here, which is that the return type does not match. What should I make get radius? Void is stupid. I should not have done that. Yeah, it ought to be an int. And why did I make a circle limited to integer versions of radiuses? I don't know, so I'm going to change that to double. Double radius and then double get radius. It returns radius. And then set radius needs to take a parameter. So double radius, void set radius, parentheses, double radius. This dot radius equals radius. And I think I've already explained, oops, excuse me, not this dot, this arrow, this dash arrow. Difference between this and Java is that you have to use the arrow reference, because this is a pointer. And when you access a member from a pointer, you can do it in two ways. You can do it with a hyphen greater than, or you can dereference it with a star, which lets you get away with using the point nomenclature. Right, that's going to go away. That arrow's going to go away. Nope. All right. Forget that. We'll go with the arrow. And why did we need to do that? Because otherwise we have variable name confusion. We don't know whether radius refers to that or that. You can get around that by using a different variable name here. If I made this double x, then I could do radius equals x. But this is very common. And I usually use this throughout the entire code base. So I would do return this hyphen greater than radius as well. Completely unnecessary at this point because there's no other variable that it could get confused. All right, and then let's do get area. So double get area. It doesn't need to take any arguments. And it's going to return pi r squared. All right, remind me how to get a hold of pi. I thought I'd included CMath. M underscore. All right. Hopefully that'll work for everybody. M underscore PI. You better work. Is it all lowercase and I just typed it in uppercase? Do I need to include math.h? Forget it. I'm going to make it 3.14159. I know we established that earlier. Somebody remembers, right? How do you get a hold of pi in our browser, in our source file here? We have done that, right?
Yeah, I think we did. I can't remember.
Does it include math? C-math?
Yeah, whatever. Okay. It's not working. 3.14159. All right. So we are not done yet because right now all of those functions are marked as private. All of those methods are private. So if I went down here into main, I'm going to move my curly braces a little bit to make it possible to get more code on the screen at the same time. All right, so when I do circle, C1 is equal to new circle. Great. And then I can do, oh, that's not the correct syntax, that's Java. Circle C1, and C1 dot set radius. I want to set the radius to 10. That's not working because it's private. All of those variables and methods are private because that's the default state until we start using the keywords. So here's what I'm going to do. I'm going to come up here and I'm going to just put public colon. And now everything inside it is public. Now really I'm going to make the variable radius private at some point really pretty soon. So what I should do is do private colon to list the radius. I may even put them on the same line. And then public colon for everything else. And like I said, the Java programmer in me wants me to put public in front of every method declaration, but it's not necessary in this language. Now that I've done that, if I go back down to main, yes, I can create. Okay, so say I'm going to write a function called print circle. And I don't want it to change the value of the circle. So what I'm going to do is I'm going to declare the parameter that it accepts as being a const. So void print underscore circle, and it's going to take a circle, so circle C, but I'm going to make it a const circle C. Let's get the area of it and we can print it out. So double area is equal to C dot get area, parentheses in parentheses. I'm getting an error. Just go with it. And then C out, arrow, arrow, quote, circle, radius equals, end quote, arrow, arrow, C dot get radius. And then C out, arrow, arrow, quote, space, area equals, end quote, arrow, arrow, C dot, wait, we've already got the area, so just area, arrow, arrow, E and D out. So the reason we're getting errors there is because const means that we're writing a contract with ourselves that we're not going to do anything in the code that could potentially change that data. Now, why would you write that contract with yourself? So that when somebody else is editing the code, if they ever, or you, 2 months later after you've forgotten what you wrote, if you ever call this function and then you modify the function so that it does change something in C, does change the values in the circle, it's not supposed to let you do that. The compiler is supposed to forbid it. It just saves you and other people who are modifying your code from making mistakes. So I want that to work. So what I'm going to have to do is I'm going to have to tell the compiler, oh, get area it's safe to call because get area doesn't change any of the data. And if we look, it doesn't. It just returns. So I can go and add the const keyword there. Saying const means that now, once I save it, try to rebuild it, that error goes away. I still have one for get radius. But get radius is the same thing. It does not change the data. So I'm going to come up here and change get radius to declare it as const as well. Now what if I made set radius const? This is bad, and it lets me know that it's bad. What it's saying is that, oh, that set radius method was supposed to be const, meaning that we're signing a contract with ourselves that it won't change any data in the circle. And what's the very first line of code? It's trying to change data in the circle. So that will not work. You will see some programmers who go nuts with the const keyword, and they add it to all of their parameter names. You don't gotta do that. Okay, so now that we have print circle, we can go down to main, and after we created our circle and we set its radius, we could call print circle and pass it in. And if we want to pass it in the fastest, most efficient way possible, we would actually declare this as a reference, which we do with an ampersand in front of the data type. Nope, that's not right. Excuse me. It goes between the data type and the variable name. And I think I've explained why that's faster. Because if you leave that off, then it does a pass by copy. Now copying a object that only has one double in it is not expensive. But this could conceivably be a very large object. We don't want to pass a copy of it all the time. Instead, we just like to pass the object itself. But that's why we're making it constant. It's slightly risky to pass a copy of the object itself because what if that code changes something in it? Well, we're not going to allow it to. So I'm going to come down in here, and after I call set radius, I'm going to print it. Print underscore circle. And I'm going to pass in C1. All right. And there we go. The circle is 10 and the area is 314. Which is to be expected. Now I was talking about forbidding bad values. If we were going to forbid bad values, we would have to start this circle off with a valid value, and we would have to make the setter not allow invalid values. So what if a circle has to have a non-zero radius? Then we could start every circle off with a radius of 1. I'm going to come up here and set the radius equal to 1 by default. And then I could make set radius check to see if this variable was greater than 0. And if it's not greater than 0, then we could print an error message, or we could throw an exception, or something like that. Throwing an exception is actually the most common programming paradigm, but we haven't talked about exceptions. We need to do that very, very soon. I don't know if I really want to do that, but you get the idea, right? I would just do if radius less than 0, or less than, yeah. If radius greater than, why not? If radius greater than 0, then this arrow radius equals radius, else, see out, quote, radius cannot be or must be positive. Programming error. something like that, right? The user's not going to want to see a ridiculous message like that. That's why I hesitate to actually have us do it. But I want you to have the idea. The data is encapsulated. The radius will never become a negative value at this point. Now, would it hurt for the radius to be a negative value? Not for calculating the area, because pi r squared, if you square a negative number, it becomes positive. But what about circumference? The formula for calculating the circumference of a circle is 2 pi r. And if the radius was negative, it would return a negative circumference, which is an idea that kind of hurts my brain. So, I'm not going to allow it. Unless I specify that I want you to forbid invalid values, you don't have to do this kind of thing inside your setter. And I think I've already, sometimes I get lost between whether I've said this in Java or whether I've said it in this class. Some people will claim it's overkill to make a variable private and then add getters and setters to it. Because we could have written this just by making this radius public, not having these two guys, and then modifying our code so that every time we wanted it, we just did, c.radius is equal to 3, or c out arrow arrow c dot radius. There's nothing wrong with doing it that way. It's just that to teach yourself good programming habits, you ought to be thinking, is there a reason to be making my data private? If you're doing it in a professional setting and you're creating a more complicated class than just something that totes an integer around, then you may strongly consider data hiding. But you may decide not to. If it makes it that much easier, whatever makes the code easiest to read, that is one important thing to consider. But the other important thing to consider is making sure that people who are using your code, including yourself, can't mess things up. And if doing data hiding helps that, then yes. And the larger the project, something with hundreds of files in it or whatever, then data hiding becomes more and more important, because you want to make the surface upon everything that all the code is based on as bulletproof as possible, so that other people coming in to work on your project, when you have hundreds of programmers working on the project with you, they can't make mistakes using your class. And if you make any changes to it, but the data hiding was implemented, then it will not break their code that you changed the internal structure of the class. Just like when the pharmacy swaps out the ingredients, All of your medicine has both an active ingredient and an inactive ingredient. And in theory, the contents of the inactive ingredient does not matter. Now, in reality, the inactive ingredient can have a big effect on the way that some people's bodies affects it. But supposedly they could change the formula of the inactive ingredient and you wouldn't know. You'd still have a bleed pill and you'd still take it and you'd feel good about it because it was encapsulated. You didn't know the internal workings. Do I need to stop? Anybody getting syntax errors that they would like help correcting? Any questions so far?
I solved the pi issue.
Oh yeah? How do you do it?
I had to use math defines at the very top.
So, £, define, what's the syntax?
It's underscore, everything capitalized, use underscore math, underscore defines.
Math defines like that?
Mm-hmm.
Okay.
Take out the last underscore. Everything last underscore.
Okay.
And it's
And then I can use math.py down here.
is the m underscore pi all capitalized.
Yeah, what do you know? Excellent, thank you. Part of me rebels strongly about having to do that, but whatever. So, an object is a variable that contains an object is just like any other variable. You can store it in an array, you can pass it around. Here we're passing it around as a parameter. We could create an array of circles. I think I'll do that. I'm going to come down here. And so, circle, I'm going to call it set unless set is a keyword. And I want 3 circles in my set. And so set subscript 0 is equal to C1. And then I could create 2 more circles and set them as elements 1 and 2, right? Not going to bother doing that. Well, I guess I could create circle C1 and then create circle C2 and C3. What would be nice and what we should implement is the ability to do this. Here's what I would like to be able to do. Circle C2 and then say, I want that one to have a radius of 20. And then circle C3, I want that one to have a radius of 30. However, we can't do that because we do not have a constructor for the class. A constructor allows us to pass in data when the class is being created. We're going to go and add a constructor. So I'm going to scroll back up to my circle class, and as the first method after public, it's going to just have the same name as the class itself, and in parentheses, and I want it to be able to accept a variable, double radius. And what's it going to do? This dot radius, not this dot, this hyphen greater than radius equals radius. Now those errors should go away, and yet I'm seeing them down here. No default constructor. I broke the code. The default constructor is a constructor that doesn't accept any parameters and it doesn't initialize anything. And the compiler gives you a default constructor by default. Sounds silly. In other words, we don't have to add a constructor that doesn't accept any parameters. One is given to us by the compiler, and that's called the default constructor. However, once you add a non-default constructor, once you add a parameterized constructor, a custom constructor, a constructor that accepts data, the compiler stops giving you a default constructor, which is sometimes is fine. But we're seeing here that I'm unable to create the array, or it broke this syntax. I could not create a circle without specifying a radius. Now, sure, I could just edit that, right? You know, I could pass in a radius, but I want both syntaxes to work. And especially, I want to be able to create an array of circles. So I'm going to go back and add a default constructor as well. Circle, parentheses in parentheses, and it's not going to do anything, so I'm just going to put a pair of curly braces. I'm going to go and modify something about my array code as soon as I do this. So I'll make sure everybody's got that. Please tell me to slow down. All right, so back down here, here's what I want to do. I'm going to delete that, or I'm going to cut that array declaration. I'm going to move it below there. And here's what I'm going to do. Circle set, not really liking that name. But anyway, set subscript 0 dot set radius 10 or 1. And then set subscript 1 dot set radius parentheses 2. Set subscript 2 dot set radius subscript 3. See what we're doing. Set subscript 0 is a variable of type circle. So it's an object of the circle class. And we can call all the methods on it just like we could when we were using individual objects, like that one. Now, along with constructors, there are destructors in this language, not in every language. The constructor is called when the item is created. The destructor is called when the item is being destroyed. Now, we don't really have to create destructors unless there are things that need to happen when we are done using the object. Like if you open a file in the constructor, maybe the destructor has to close the file. Or if you allocate memory with a malloc command or some other way of allocating memory, then you need to free that memory when the object is no longer in use. The syntax for a destructor is this. It's the same as the constructor, but it has a tilde in front of it. And by the way, Java doesn't have destructors, but let's go ahead and add a destructor. So, tilde, you know, the value above the backwards apostrophe next to the 1 key, and then circle. Destructors do not have parameter lists. And I don't know what I'm going to make it do, so I'm going to just make it print out a message. A circle is being destroyed. \n. So what can destroy an object when the variable falls out of scope? Well, look at that. I lied. All of those variables are falling out of scope, and the destructor is not being called on them. That's okay. I'm going to do a test. I'm going to come down here, create a new block like this. In fact, I'm going to do it right here. I'm going to put an open brace there, a closed brace there, and see if it prints any message as those two variables fall out of scope. Yep, yeah, there we go. We're seeing a circle is being destroyed because these two variables are falling out of scope at that point. Their memory is being released. And in order to release their memory, part of that is the destructor. And if there was something special your class needed to do, then you would add a destructor. There's kind of a default destructor anyway. It's just like the default constructor. But we're replacing it with one of our own if we need some kind of custom behavior. Specifically, if we were allocating files or using other resources that we needed to free up. Why would you want to do that? Well, what if your constructor opened a file and you had this inside a loop and you were creating 1,000 circles? That file was being opened 1,000 times and never being closed. That would be a problem, right? You would have multiple instances of a file, or you might have 1,000 different files. That's known as a memory leak. When you're allocating a resource in a class, but then when that resource is done being used with, it's not released. The Mozilla, the Firefox browser used to be notorious for memory leaks. You would run it, and if you didn't kill your browser after a while, you come back a couple of days later and it'd be using hundreds and thousands of megabytes of RAM. Nowadays the program's much better behaved, but they had to go and they had to fix all the memory leaks. So, when you define a member function, if you don't actually put it within the class keywords, you have to prefix the name of the method with the name of the class that it's in. So, here's what we ought to be doing, which we haven't been. And I think I'll only do it with one of the methods of my circle class. I'm just going to make this a prototype right there. Get area is just going to be a prototype. Maybe we'll do it to all the functions, but it makes the code messier. And I object to making the code messier, but we're going to do it at least for one of these. Why don't we add a get circumference? But we're going to do it in a way that we're showing. So double get circum, and it's a const, and there. Oh, all right. I'll remove the const keyword. Now I'm going to actually put the implementation of the get circumference function here. So circle colon get circum, but I need to go back and put the keyword double in front of all this stuff. So I will do that in just a moment. So double space circle colon colon get circum. And it just needs to return 2 pi r. Does it not?
You have your double get circum in front of inside of the get area braces.
Oh, yeah. Okay. What I do wrong, I have this inside a curly brace where it shouldn't be. Thank you for spotting that. I was about to get irate. Okay. And down here, we could return 2 times m underscore. No, wait. You know, m underscore. Yeah, it's just 2 pi r. 2 times m underscore pi times the radius, or this arrow radius. What you're supposed to do is take that class definition, not put any of the function code in it, just function prototypes, and then move it to a header file called circle.h. And then you're supposed to define all of the prototypes. Excuse me, you're supposed to expand upon all the prototypes. You're actually supposed to put all the implementations in a file called circle.cpp. So we're going to not move the circle class around, but we're going to create another class that has the same idea. We're going to create a triangle class, or the rectangle class that the code that the book talks about. So I'm going to come over to source files, and I'm going to do add new item. Excuse me, I'm going to do add class. Add empty C++ class. Okay, fine. What is the class name? RECT for rect. The header file for it is going to be rect.h. The CPP file for it is going to be rect.cpp. I'm not making any changes to that. Now, if I chose inline, that would mean that I was putting the functions, the methods, in the header file along with the class definition. But I'm not going to click that, and I'm going to provide the function definitions, the method definitions in the CPP file. And Tune, Vincent, I'm sorry to have to inflict this on you because Java does it so much more nicely. It does not separate it into a header and a CPP file. But we got to do it both ways. Okay, so here's my header file. This is the generated code. And notice it added a default constructor for us just to remind us that there is one. Makes it real easy for us to change it. And it adds a destructor for us. Great. I'm not going to touch those. But I am going to add some private data. Private width, private double width, and private double, excuse me, it needs to be colon. There I slipped in the Java syntax. Private colon, and then on the next line, double width, and then double height. And now I'm going to add a get area and a get perimeter prototype. So I should add getters and setters for width and height. That is so tedious, I'm going to be a terrible programmer and just make these public. Or no, I'm going to make a constructor that sets those values. So, rect that takes double width, comma, double height. Now, along with those functions, we're going to add one for get area. So double get area, parentheses in parentheses, and it's going to be a const, except I don't put the keyword const there for some reason. Only if I'm declaring the method in line, the class. Can I use the const keyword there? Otherwise, I'm going to have to use it in the CPP file. And we're going to end this in about 3 minutes because my voice is going bye-bye again. So that's my rectangle class. That's the header for it. That's the skeleton. That's the declaration for it. But now we have to go to the CPP file and add code for these functions, specifically that one and that one. So I don't want to toggle away from this until everybody's got this. Does everybody have this? Slow down. We're good? All right. So go to rec.cpp. If it's not open, you can find it here. It already filled in the two functions that were created by Visual Studio when we said we wanted a new class. But we know that we have another constructor that we want as well. So rect, : rect, looks silly, parentheses, and we need to specify those parameters, double width, comma, double height, and I hope I don't have those backwards. I'm going to blip back to my header file to see, make sure I have them in the same order. Yep. And what's it going to do? This hyphen greater width equals width. This hyphen greater height equals height. And then I'm going to add a get area. Same business. I have to, oh, I've made a mistake here. I did not give it a data type. Oh, no, that's correct for constructors, but it's not correct for get area. So double space, rect : get area, parentheses in parentheses, const, because when we're calling get area, we're not changing anything. Alrighty, apparently we were allowed to use the const keyword in the header file. I don't know why I began to think that that wasn't the case. I'm going to get... Alright, good. Okay. So I went back to the header file. I added const there. Now I'm going back to the CPP file. And the area is just the width times height. So return width times height. Or return this arrow width times this arrow height. Now, wasn't it nicer when we were putting all this stuff inside the class? Yeah, it was. Do a lot of programmers just put the entire class, including the methods themselves, in the header file and not have an associated .cpp file? Yeah, a lot of them do. But this is how we should do it. Difference between theory and practice is sometimes people will do what makes the code easier to read. And what do I mean by that? When I'm looking at the header file, it's nice to be able to just put my code right there. But with the idea of data hiding and stuff like that, theoretically we ought to be able to give somebody the header file for the rect class, and they don't need to know the details, the guts about how the methods work. So in that case, we give them the header file, and then we give them the compiled versions of the libraries, which include the CPP files, but we don't give them the CPP file themselves. So they don't actually get to see how that code works. They just get a header file, and then they get a file that they can link to that implements the circle class, and they're good to go. Alright, so now that we have this rectangle class split across the header file of the CPP, we're going to go back to main and we're actually going to create. I'm changing the way this looks just a little bit so they can all be on one page. And there we go. That is the entirety of my current rect.cpp file. In this particular case, do we actually have to have a constructor and a destructor? There's nothing wrong with leaving them there so that they can be fleshed out later. Okay, I'm going to go to source.cpp and go down to my driver code in main, and I'm going to create a rectangle. Rect R1, and it's going to be a 20 by 30 rectangle. But I'm getting an error because it doesn't know what a rect is. I have to go and add a # include. But it's not going to be # include angle braces, rect.h. It's going to be # include quote, rect.h. So let me scroll up here to all my includes, and # include quote, rect.h. What's the difference? The angle brace tells us that it's part of the C library, and that it's supposed to search the library search path. So the compiler goes and it searches all the search directories for that header file. The quotes mean nope, it's right here in the same file as the one that we're currently editing. And if we put braces around it, it won't even be able to find it because it's not part of the C library. It's something we created. So. Okay, so after you've added the # include, quote, R rect.h, let's go down to main. We created the rectangle, and let's use its area. Double area equals r1.get area. And then we could do something else, right? We could print out the information, something like that.
Can you go to the rec CP or C?
Yeah, sure. And then we're going to have, I can only think of one thing. I don't know how to create the perimeter of a triangle based on its height and base. I don't think that's possible, but we certainly can get the area. Add a get area method, a get height method, a get base method. The formula for get area to return is 1/2 times base times height. We also want to add a set base and a set height method. If I was going to outline this in a slightly more concise format, I would use what's known as UML, and it would look like this. The name of the class is triangle. The variables in the class are private, so I'm going to put minus signs in front of them. And we had two variables. One was base or height, and it's a double. And then another one called base, which is also a double. And then we have some methods. I'm not fond of those plus signs. All right, that looks better. And this is all, I should be doing this in Word and making it look nice. Okay. And then the third section of UML, it lists all the methods. So we need, they're all public, so we put plus signs in front of them. We need get height, which returns a double. We need get base, which returns a double. Need set height, actually, yeah, which accepts a variable and doesn't return anything. The variable accepts as a parameter as a double, but it returns nothing. And then set base, it's the same thing. It accepts a double as a parameter but returns nothing. We also want a constructor. And we want a second constructor, which takes us two variables. And we will cover this material again on Thursday, so it's not like throwing out to the wolves just with this one explanation. Have I forgotten anything? Oh yeah, get area, which doesn't accept any parameters but returns a double. I will leave it up to you as to whether you're going to separate this into a CPP and a H file, or if you just want to put the functions in line. Makes sense? Pretty similar to what we've done? UML stands for Unified Modeling Language. Not sure that this textbook discusses it. Don't recall. Alrighty, let's make a Dropbox.